Welcome to the teaser class 1, Zoom SPM Intensive Echem 2022. So actually, for today's class, the subject will be the biology for the Form 4 Chapter 3, the movement of substance across the plasma membrane. So I'm the hero of the day. So you can, actually my full name will be the Mr. Chen Xijin, and my qualification will be the PhD in bioscience. And the below are some achievements achieved by me in this recent year. So for first, actually, I'm a scientific writer at the China Press newspaper. So for the person who can read and write in Mandarin, so the newspaper name will be the 中国报. Okay, so and at the same time, I was also a scientific speaker at the Bioscience Malaysia 2 years ago until 2021. And previously, I was also a lab coordinator of enzyme research lab in the UTM Skudai, Johor. And lastly, I'm also a vice coordinator of Microbe World 2019. Okay, so guys, so can you all give a hi to all the attendants today? So you can say some hello to everyone here. So is anyone can reply in the chat box now? Let me see who are you. Oh, no one. Oh, hello, Miss Yuki. And hello, Wei En. Hello, Kai Qing. Yeah, welcome. I think that Kai Qing is a student who firstly joined our Echem for the first time today. But previously, there are other two who was my previous student. Okay, so for today, I will share you some formula to get A+ in the Zoom SPM Intensive Echem. Okay, so for first, I will separate this one in two different sections. So for the left-hand side, in this live session, so actually after we start the session, you will having a lot of the live session from January until the end of February. Okay, so for sure that in every live session, you must be very focused. Okay, why? Because when you focus to learn the thing, at the same time, you will know that actually what is the content that you don't really understand, and you can ask the question straight away in the live session. So most of the students, based on my study, most of the students who can ask the question in the live session or even in my tuition class before, normally their result will be average, will be get better. Most of them will get at least B+ and even A+ in the exam. Okay, and after you finish the seminar, every live session, okay, so actually our L&G team have prepared some question bank for you. Okay, so for every topic that you learn in the live session, you can try to do the online question bank in the Google Classroom. Okay, so in the Google Classroom, your answer will be marked by our tutor here, include me. So for subject biology, it will be my responsibility to mark all the paper done by you all. Okay, and then you will get your marks, and we will do the statistic for you. So in which chapter you will be the weakest, and you can try to consult me during that time. And lastly, okay, we have the ask question section in our private group, no matter it's the Facebook or in the Discord. Okay, so for some students, you think that, oh, I want to take the paper in English, but then my English is not that good. But don't worry, actually in the Discord or the Facebook section, you have a section that you can ask the question in Chinese, in Mandarin. Okay, so for most of the tutor here, actually we are able to communicate in the Malay and Chinese very well. So we can also reply the question in this language as well. Okay, so yeah. So I think that's all. It's a simple introduction about the formula to get A+ in the Zoom SPM Intensive Camp 2022. But as the first teaser class here, I also want to share you all that in our coming Friday, we also will have our teaser class 2 about the chemistry topic. Okay, so if you think that today class is still okay, not that good, maybe you can try to test our another tutor class, which is from the Miss Lam Yen Dong. Okay, so she's a very professional tutor who can give a very efficient class to you all. Okay, so for topic of the day, today I will try to explain about the Form 4 Chapter 3. It will be about the movement of substance across the plasma membrane. Okay, so I guess that most of the students, no matter you are from the UEC syllabus, SPM, You also either syllabus will having the very important emphasize on this topic about the plasma membrane. Why? Because actually the plasma membrane will be the one that powered by our cell. Okay. So in this live session, I will only share the key point that will help you to answer the SPM question. But for sure that if you think that your theory is not really strong now, you also can ask the question in the tutor group. So do remember. And at the same time, if you think that the theory question that must be solved right away, please write your question in the chat box now. For example, I put a hi here. Okay, so you all can try to type the question here, and for every maybe 10 to 15 minutes, I will have a short session to check on the question, so I can answer your question straight away after that. Okay, and the host will also record the question for me if the session is very rushy and we don't have time in the middle. Okay, so don't worry about that. Okay, so for the floor member of the day, today we will talk about the plasma membrane. So for the plasma membrane, anyone have the idea? Can you all type some answer about the plasma membrane? So for example, like me, plasma membrane is a very thin membrane. Okay, so any other answer? Can you all try to show me your answer in the chat box? Let me check the chat box here. Yeah. Lipid bilayer. Yeah, it's a good point. Phospholipid. Yes, very good. Okay, thank you very much from the floor member. Okay, so just now, our floor member, I saw the Miss Yuki and also Miss Wei En state that. Hey, sorry, my tablet is now on. Okay, so sorry for that. So just now we saw the floor member share that actually the plasma membrane having some very critical term to explain about it. So the first one they say is a bilayer. And another Miss Wei En say that actually there's a term called as phospholipid. Okay, so let me combine this one together. So actually it's a kind of phospholipid bilayer. So from the picture you all can see on the right hand side, actually the picture will be, you can see the plasma membrane here showing a two layer of the membrane. Okay, and that's why this is the meaning of bilayer. What is the meaning of bi? Okay, meaning the bi is having the meaning of two or double. Okay, so the phospholipid bilayer, this term is very important in answering the question. Okay, then how about the phospholipid? Okay, so for sure that when we talk about the phospholipid, this will involve the knowledge from other chapter. But since I assume all of you here already have some fundamental knowledge in the SPM syllabus, so let me straight away to reveal the answer. So for the phospholipid, so means that actually the phospholipid is made up by phosphate plus lipid. Okay, and other than that, if I draw a figure like this here, this is a very simple diagram. I draw a figure like a circle and two lines. Can anyone in the floor member here can tell me what is the part X and Y here? Yeah. Let's see who is the student who can answer the most. Maybe I can give her some present at the end of the class. Anyone know what is X and Y? So let's wait another 20 seconds. Okay, since no one is answering, so sad to know that, because I thought that I can give some voucher later. Okay, for this X and Y, so what is the phospholipid and how to label them? Okay, so in the SPM exam, one of the popular question here is what? Please label X and Y here. So for the X here, normally we will label them as a hydrophilic head. And then for the Y, we will label as the hydrophobic tail. Hydrophobic tail. If you don't really understand about the what is the meaning of hydrophilic and also the hydrophobic, okay? So actually for the meaning of philic means what? Philic means love. For phobic means hate. And what is the meaning of hydro? The meaning of hydro is water. So it means that actually the phospholipid bilayer having a part of love water. They love the water here. And then they hate the water here. The tail is hating the water. Okay. So these are some very critical points that you must understand in the actual SPM exam. And let's proceed to the function of the plasma membrane, because I had put several key points here. Okay. So for the first one, when they ask you the function of plasma membrane, okay, so I already highlight the point for you. So in the exam, normally if you state that it allow, what's the meaning of allow? You say yes to something to do something, okay, but it allow and regulate. Regulate means it will control it. So that's why some of the students ask me, so if I don't really good in English, so can I write control? Yes, you can write control. So the key point you can write is allow and control the substances in and out of the cell. Okay, well, this one is very important. Why? Because plasma membrane can be in and out. Not must be bi-directional. Okay, so important here. Another star. Okay, and next I want to talk about is the fluid mosaic model. Okay, so in exam sometimes they will say, what is the meaning of fluid mosaic model? Okay, so if I show you the figure on the right hand side, okay, so you can see, if you imagine, what is the mosaic? Mosaic actually is the shape, or you say the substance they put on the floor, so your floor will look very flat and slippery. Okay, so but why this fluid mosaic model have a term fluid? Okay, the fluid having the meaning of liquid. Okay, so for the fluid mosaic model, so you can imagine, if let's see here, everyone. Okay, so for here, you all can see that actually, if I draw the mosaic on the top of the plasma membrane, hey, you all will discover that, hey, sir, actually the plasma membrane is like keep moving, okay, but it cannot stay consistently. Yes, actually the one of the critical term to describe the fluid mosaic model is they keep changing. Okay, so the fluid mosaic model state that actually the component on the plasma membrane. Okay, so what are the components? We will see later. Will keep changing their places. Okay, they're ever changing, or we say keep changing or ever changing, having a similar meaning. Okay, that means that doesn't able to stay in the place. Okay, and they are selective permeable. One of the famous answer in SPM exam also, when they ask the permeability, there is only two answers. You can write either the selective permeable or the semi-permeable. Okay, both will be acceptable. And last one, the key point, I put the question mark. Why? Because actually we can try to guess what is the thing on the right. We can, let me change my pen color. So you can see, hey, this is the component that I can see on the plasma membrane. But why teacher you doesn't want to show me? But if I ask you all, can you tell me the name of this component? Anyone can answer it. Yeah. Any good student here can answer this? What is the thing that I highlight for this one? Anyone know what is this? The purple substances. Protein channel. Oh, Miss Kai Ching said this is a protein channel. Then Miss Wei En say it's a channel protein. Oh, very good. So can you all guess that who is the correct answer? Protein channel or channel protein? Okay. So actually for SPM, the official answer for this one will be more towards to protein, channel protein. Okay. So let me write here. Yes, it could be the channel protein. But good try from the student. Okay, it's a channel protein. So is there any other component? Let's see the next figure. Okay, so yeah, so this one is the picture shared by the Science and Medicine from the website. Okay, so this one is a very straightforward figure to learn about the plasma membrane. Okay, so for this plasma membrane, yes, just now Miss Wei En said that yes, this one is a channel protein. Well done. But if you ask me, so just now Miss Kai Ching say, is protein channel acceptable in SPM? Actually, the answer is yes, but let me change the font color now. But it used to describe on other aspect. Okay, so for the structure, channel protein will be the most correct answer. Okay, but in this figure, actually, I intentionally to not draw another type of protein. Can anyone here know that? Can anyone here can tell me? Can anyone here can tell me what is the another name for another type of protein in the plasma membrane? Anyone have the idea? Other than channel protein, we still have another type of protein. And the way to draw that one is totally different from this one. Channel protein always having a very simple structure like this one, for example. Okay, so this one is the channel protein I draw. Don't laugh me if you think my drawing is very ugly. Anyone have other idea? What is the protein that I can draw here? Not sure. Okay, don't worry. Okay, so let me tell you all the answer. So another type of protein we can draw is what? We can draw the carrier protein. Okay, so how to draw a carrier protein? For carrier protein, normally the middle part here, okay, so will not be so flat. So normally they will accommodate a specific shape here. So for example, some of the students will draw like this. So in SPM, if your year is very lucky, they ask you to draw carrier protein. So normally one of the carrier protein you can draw is like this. So normally there are some shape in the middle of the protein. Why? So let's talk the thing further into every part in the plasma membrane. Okay. So for the first one I want to share here. So for the first one, you all can see glycoprotein, glycolipid. Okay. So student always confused. So sir, why the protein have this protein on the surface look the same? I don't know how to label glycoprotein. I don't know how to label the glycolipid. Okay, so let's see. Actually, when you learn the way to understand the term from me, you all can understand that actually the labeling is super easy to achieve. Why? Let's see here. What is the meaning of glycol first? Glycol means having a meaning of carbohydrates. Because it could be the you can try to link the memory to a substance called as glycogen. Okay. And then what is the protein and lipid? Yeah, very straightforward, right? Protein, lipid. Okay. And so let's see the structure. Okay. Glycoprotein. So you can notice that here is the protein. But another part, here is the, sorry, glycoprotein. I put the wrong labeling. Here is the glycol. Here is the carbohydrates. Okay. And then another part is protein. So that's why you can see glycoprotein means what? Carbohydrates plus protein. Same to here. Okay. So same theory will apply to the glycolipid. Okay. So you all can see that here is the carbohydrates. Here is the lipid. Okay. So glycolipid means that carbohydrates plus the lipid. Okay. Yes. Very straightforward, right? Okay. So let's think further about the functions. Okay. So most of the students will have a question. So sir, so we can when I see the figure from the internet, when I see the figure from the exam paper, when I see the paper from the UEC teaching, from the lecture, from my school teacher, actually, why there are so many glycoprotein or glycolipid on the surface of plasma membrane? Okay, so in SPM, the answer will be simpler, to be honest. Why? Because for no matter the glycoprotein or glycolipid, the function is only very short. We just put cell recognition. Okay, what is the meaning of cell recognition? So for example here, let me see the 4-member tonight. This afternoon. Okay, so I can see, so today our first wave of attendance in the teaser class 1 is, I can see the Miss Wei En, Mr. Edward, okay, Miss Kai Ching, and also Miss Iki. Okay, so normally for human, we can say, oh, we use the name to recognize the people. So if I see Miss Edward, so Miss Edward is a guy, so I know this one is a Miss Edward. Okay, so Miss Kai Ching is the girl, look like that, and so on. Okay, but for cell, for a very small cell, they don't have the way to recognize the people like that. Okay, so how to do that? Okay, so they use the shape. Okay, so they can identify the people by the shape. Okay, so it means that maybe shape A equal to, you know, this one is the cell A. Shape B equal to cell B. Like that. Okay, very straightforward. Okay, and then next, we have another new member that we always can see in the plasma membrane. Okay, cholesterol. So where is the cholesterol? Normally, the cholesterol will be at the middle of the plasma membrane. Okay, and what is the function of cholesterol? Okay, so as our this one is a simplified class, so we have the answer straight away. The keyword is what? The cholesterol provide stability. And another term, fluidity. So you all can imagine, cholesterol is like the nail in the plasma membrane. When these two layer of the phospholipid bilayer is like the two piece of the wooden board. Okay, so they are like sliding each other very vigorously. So the cholesterol actually will control the fluidity. So for example, like today, oh, this plasma membrane look like too fluidity already. in Mandarin, we will say like 吐水水, okay, 很水 like that. Okay, but by the function of, due to the function of cholesterol, okay, the cholesterol will try to increase the fluidity, decrease the fluidity, so that the phospholipid bilayer will not move so much. Okay, so in SPM, you just need to remember two terms: stability, fluidity. So if you're able to understand what is stability and fluidity, you can already explain the question. Okay, so and lastly, we talk about the protein. Just now we say we have the channel protein, we have the pore protein and a carrier protein, so on. Okay, so what is the function of protein? So let me state lastly in the slide. And don't worry for the floor member tonight, to this afternoon. Actually, for the slide I jot down just now, we will send you a clean slide and also a sketch slide. So for the sketch one, you all can try to read. If you cannot understand, please ask me in the group. Okay, so I can answer you every day. If actually for me, you can start to find me from maybe from 9 a.m. until 3 a.m. Okay, so if you have any question, normally I can see the question straight away. Okay, I want to talk about the protein. Okay, so for protein on the plasma membrane or in the plasma membrane, we don't really emphasize that much first. We say that actually the protein are used for transport. Okay, so first part is what? First part is about the active transport and also the passive transport, which we will discuss later. Okay, and then yeah, so that's all about the very fast recap about the structure of the plasma membrane. So if you have any question, please write your question on the chat box. If you do have any question, maybe you can say, yes, I'm okay in the chat box, okay? So I can know that, yeah, every one of you here can understand my theory very well and let me to improve again after this, okay? So you all can, I leave you all for maybe 10 seconds. So if you think the content is okay, please type okay. If you have question, please type your question, okay? So yeah, please. Let me see the review here. Okay, Miss Iki and Wei En and Miss Kai Qing is taking okay. So thank you very much for the feedback. Okay, so next, let's go to the next class. Next part. Okay, so let's go for the first example here. Okay, so which of the following component can be found on the plasma membrane? Okay, so this one is a very tricky question in SPM. This one is a model question. So I leave another 10 seconds for you guys here. So you all can try to read the question and choose the answer. Okay. So let's see who is the best scholar of today's session. You all can type A, B, C, D, A, B, C, or D in the chat. Let me see who having the correct answer. Based on what I taught just now, what is the answer? Mr. Edward say it's D, all of above. Whoa, okay. Any other answer? Thank you, Miss Edward, for the fast response. Miss Wayen also say it's the D, all of above. Miss Iki is also say D. Okay, very good. Miss Kai-Ching also say it's D. Okay, but yes, congratulations to all the students here today. So the answer is not D. Okay, so let me explain further. Okay, so normally when we say about the component that can fall on the plasma membrane, so the final answer is C. Okay, what is the reason? The answer is 2, 1, 3, and 4. Okay, cholesterol. Yes, just now we know this one. Okay, provide stability, or we say provide fluidity. Secondly, channel protein and carrier protein for transport of substance. But how about carbohydrate? So all of you agree that, oh, teacher, sir, I know that carbohydrate should be correct, but so sad to tell that actually carbohydrate is not the best answer in this topic. Why? Because for carbohydrate, it will not be stand alone or present alone in plasma membrane bilayer. Okay, it will not. Okay, so let me put a red color here. So it will not. Okay, so it must be either combined with the lipid to become the glycolipid, or it must combine to the protein to become the glycoprotein. Okay, so that's why, yeah. Okay, but thanks for the response today. Okay, so let's proceed to the next topic. Okay, so next topic we want to talk about the factor that affecting the transport across the plasma membrane. Okay, so there are some factors that can affect. Okay, so there are, sorry, it's not the 3, it's a typo here. I only want to put 2. So in SPM, my tips for here is only, we have only 2 factors to determine about it. Why? Okay, the first one is the size. For size is very straightforward, right? It's either small or big. And secondly, we want to talk about the polar molecule. Okay, so in the exam, we always see this thing is polar, that thing is polar, the fat is non-polar. What is the meaning of polar? Okay, so actually the polar molecule means that they're having the charge. Okay, with charge. It's either the positive charge or negative charge. Okay, so it can be with charge. It means it's a polar molecule, or without charge. It's a non-polar molecule. Okay, so if the molecule is non-polar and polar, what is the difference? Okay, so for this chapter, when you having the question that asks you, so for substance X, is substance X able to enter the plasma membrane straight away or by using any specific component? Okay, what you need to think is only think about big or small for the size, or with charge or without charge. Okay, so why? Let's proceed further. Okay, so let's see here. Okay, so if you want to enter the plasma membrane straight away, the permeable means you can enter straight away. Okay, you have two criteria to fulfill it. Okay, so if you have, the size is small, okay, if the size is small, for sure it can go through straight away. Okay, so they prefer, normally for the permeability, they prefer small molecule. And then for the secondly, polarity. Okay, so polarity is what? Polarity is, they say, is uncharged. No polarity. Okay, what is the reason? Okay, this is because we have the phospholipid in the plasma membrane. Okay, but for phospholipid, they hate water. Let me do some reasoning for you. Okay, they hate water means what? They hate the water soluble substance. Okay, and then if they hate the water molecule substance, what is the meaning? Okay, so if they hate the water molecule, they hate the water soluble substance. Water soluble substance actually referring to charge. Okay, means they hate anything have charge. Okay, they hate the charged molecule. Okay, so anything as long as this water soluble. So actually, I know that most of you having the knowledge of the chemistry. Okay, so for example, anything that can dissolve in water. For example, like we like to drink we like to drink the bubble tea, right? Okay, so the bubble tea use a lot of the sugar, the milk to make it very tasty. But when we try to prepare it, we need to put a lot of water to dissolve the ingredient. So all the ingredient, the sugar, the tea extract, and so on, all are water soluble. Okay. So if they are water soluble, means that our phospholipid bilayer hate them. They don't allow them to enter straight away. Okay. And then, so if you want to let the phospholipid bilayer to allow them to enter, okay. So the first criteria you can do is must be very small first and mostly uncharged. So example is all of the gas you can think. Okay. Example is what? Oxygen, carbon dioxide, nitrogen, and so on. But the student could do a mistake here. Why? Because teacher, sometimes my answer teacher will mark wrong. Then I ask the student, so what is the answer? Oh, because I put O, or maybe I put O2 minus. Okay, so this one is not acceptable. Okay, because it's not uncharged. Okay, O2 minus is very straightforward. It's negative. Okay, it's the negatively charged molecule. For oxygen, O only. Is you all having any oxygen gas in O only, not the O2? Normally no, right? Okay, so O or O2 minus are not the acceptable answer. So if you want to write the answer as gas, please remember that the gas must be right in the stable form. Okay. And then secondly, okay, so now I don't want to care any size, no matter big or small. Then if you don't care about the size, so it must be liquid soluble. Okay, so means that that can dissolve in liquid straight away. Okay, so example is what? Okay, not water soluble substance. Anything you remember is water soluble, cannot. Okay, in SPM, normally they will bind this question to another famous thing because we learn about fat soluble vitamin. Okay, So I know most of the students here like to eat vitamin because I was someone like you before. I like to eat a lot of vitamin B, C. Maybe now I'm so old now, I need to eat some vitamin E, okay, antioxidant, so I can I can get older slower. But among all the vitamin, okay, so we learn a lot of vitamin, okay. We have A, B, C, D, E, and K for SPM. Okay, how to remember who is the fat soluble or water soluble? Very easy. Okay, so for the water soluble, there's only two, vitamin B and C salt only. All other are the other fat soluble. Okay, so the answer here is vitamin A, D, E, K. Okay, so when you see a question like, so now I have the vitamin A, D, E, or K want to dissolve through the plasma membrane because the cell need to consume it. Okay, so they ask you, so what kind of the transport required? Okay, so what you need to think is about what? The permeability. Okay, so if they can permeable, is permeable means it can straight away to diffuse through it. Okay, so it means that actually the type of transport that I will explain later, you all can see again. I write here first. It will be the simple diffusion. Okay, simple diffusion. Okay, very straightforward. Okay, so next we see. Okay, so if the simple diffusion is not able to pass through, okay, so what are the components that cannot pass through straight away? For sure that as long as it is have charge, or it is liquid lipid insoluble, or we say actually it's a water soluble. Okay, so first example, for the small molecule but charged, as what you see just now. For what you see just now I say O2 minus having the charge, they cannot pass through. So means that actually all the ions, okay, because ion is either positive or negative charge, they were not able to go through the plasma membrane straight away. So example is what? We eat the salt, sodium ion, chloride ion, potassium ions, and so on. So many. Okay. So if you see any charge, you know that, oh, I know lah, teacher, this one I confirm 100%. It cannot pass through now. Okay. Congratulations. You got the idea already. Okay. But secondly, how about the molecule which is very large and also insoluble? Okay, for sure we know large thing for sure cannot. Okay, need assistance from protein, need protein to help. Okay, so what are the example? So the example will be the water soluble, for example, like what? In SPM, most common component you learn, glucose. Okay, lipid, glucose or any sugar, for example. And then if you ask me, in large but got charge, any other example from other chapter that I will do the revision with you all in future, you all will understand that actually, for example, like the charged large molecule is amino acid. Okay, so I give some tips here. Amino acid have a part of positive charge and another part of negative charge. So what is the part name? Okay, so today if I taught the theory now here, you cannot understand, it means that you haven't mastered the theory yet. Okay, so positively charged is the NH plus molecule, NH2 component. For the part of negative is the COOH. Okay. So if amino acid, what are the typical structure? I draw a very fast one here. CRH, COOH, and H2. Okay, so you know that here is positive, here is negative. Okay, so yeah, so we complete this table already. So we can go back to the question later. So if everyone here so far have any question, please ask me the question. If there are no question, you can give me an okay, so I know that, oh, this topic is too easy for you. You can master it already. So anyone okay? So Miss Wei very fast, first one to say okay already. Okay, Miss Lai Kaixin also. Okay, Miss Iki also. Thank you very much. Okay, so yeah, okay. So thank you for the fast response. Let's move to another question. Example question. Okay, so which of the following transport is suitable to transport the vitamin K? I guess this one is too easy for you all now. So which one is the answer? I give you all, oh, not even 10 seconds. Okay, I give another 2 seconds, 10 seconds. Other students haven't give the answer yet. Miss Wei En and Miss Kaixin pick A. Any other answer, possible answer? Oh, 3% choose A now. Okay. So yeah, Miss Edward also choose A. Okay. Very good. Okay. So I count down for 5, 4, 3, 2, 1. Okay. Time's up. Okay. Thank you very much. The answer is A. Well done. What is the main reason? We know that vitamin K is fat soluble. Means, or we say is uncharged. Okay, so it will be permeable straight away. Okay, permeable equal to can enter through simple diffusion. Okay. Well done. Okay, so let's go for the next part. Okay, whoa, very big table here. Okay, so we have so many transport here now. Okay, so what should we understand? Okay, so since I assume that most of you already learned a bit about the transport before. Okay, so I will explain the thing in this table, but if by the end of today's class you're still able to understand, please ask me the question, or maybe you can PM the admin to ask more about the class that help you to talk about the theory. Okay, because normally I would talk the theory into very detail during the weekly tuition class, but for this kind of the revision camp, normally I want to let the student to recap everything in 2 hours, but for today we only have 1 hour. Okay, so for sure some of the thing will be quite simplified. Okay, so for this one, so let's answer the thing one by one. Simple diffusion. Okay, so we know that actually for the movement of substance, it means that it's either from high concentration to low, or we say it's from low to high. Okay, so if we want to explain the movement of the substance, okay, so for this table I will write the full answer for you all for sure. Okay, so for simple diffusion, osmosis, and facilitated diffusion, it will be move from region of higher concentration to region of lower concentration. Okay, so this will apply to some other transport in this table. But if I ask the floor member today, so we have 5 students today. So is any of you know that which transport is not following this theory? because this theory is from high to low. Any transport is from low to high. So I give a 10-second here. Anyone know the answer? Active transport. Okay, Miss Wei-En say is the active transport. So any other answer? Any other answer? Active. Okay, Miss Iki is also talking about active transport. Okay, yes, well done. So actually this theory applied to osmosis and also facilitated diffusion. Okay, but for active transport, the theory will be in reverse. Okay, so it will be from low concentration region. I write the full sentence better. So move from region of low concentration to region of high concentration. Okay, yeah, very well done. Okay, so this will also apply to the trend of gradient. So there's only the active transport we will say is against the concentration gradient. For simple diffusion, osmosis, or facilitated diffusion, we will say that actually is follow concentration gradient. Okay. And then next one. Okay. I think this figure is a bit faulty. So next one, the direction actually the movement is the same. So this one I cancel it. Okay, so next one I want to talk about is the energy requirement. Okay, so active transport is always spatial because for osmosis, simple diffusion, and also facilitated diffusion, because they are what? They are passive transport. So they don't need any energy. No energy is required. Okay, but for the active transport, we need energy, yes, in the form of ATP. So if we continue also, so we always think active transport is so spatial that don't really follow others. Okay, so same to the any equilibrium achieve this aspect. Okay, so for this one, so is there any equilibrium achieved? Yes. Okay. So it means the equilibrium stop after equilibrium is achieved. Okay, but next we talk about active transport again. If there are no equilibrium achieved, how to describe it? Okay, so actually for active transport is no, because there are either go for accumulation, means that they want to keep a lot of things, or removal. They want to remove something from some places. Okay, so yeah, this is the purpose of active transport. So that's why active transport, you against the concentration gradient, so you need the ATP to achieve it. Okay, and lastly, the most important aspect from this four transport. So if we ask you type of substance involved, then we need to refer back the last table we learning. Okay, so for example, simple diffusion, we know that simple diffusion can be used for all the gases and all the lipid soluble substances. Okay, so we can know it's maybe the gases, and all the lipid soluble substance. And for osmosis, I know lah, most of you here now, for FUMU, you all already will enter senior 3 next year. So for SPM student, most of you always remember osmosis because osmosis is the only reaction talking about water. Okay. And for facilitated diffusion and active transport, actually there can be anything same, just depends on purpose, or maybe that involve any ATP or not. So anything is very large, or they're having the charge, or what, or they are lipid insoluble. Okay, or you can describe them what, same also to water soluble so substance, or will be involved in the either the facilitated diffusion or active transport. But if you ask sir, so sir, cannot lah, if like this I cannot understand what you write. Okay, so I give a few examples here. Okay, so I write maybe example is any ions, glucose, amino acid, and other nutrient. Okay, most of the nutrients are
teacher. Sorry.
Yeah.
Can I ask a question?
Yes, please.
Why no direction of movement? The direction of the low concentration to high concentration is not the direction of movement, man.
Yeah, so that's why I already repeat at the movement of substance, right? So I don't want to repeat the same thing again. I think I do a typo here.
Oh, sorry.
Yeah, it's okay. Thank you for asking. No problem for that. Okay, so yeah, so just now, who is your name? Can you tell me your name? Yeah, who is the one? Sorry. Yeah, who are you? Yeah, just now I didn't see your name. Oh, okay. Thank you, Mr. Edward. Okay, yeah. So thank you. Actually, just now actually is these two are for me is referring to the more or less thing. Okay, so that's why I don't repeat anymore. So sorry for that. I think I did something wrong in the slide last time. Okay, so yeah. So this one is the simplified version. So that's why if you all already have the theory, study some theory already, then I apply this table to you. You can answer the question straight away already. Okay, so that example of question for sure here. Okay, so any question? Any more question other than Mr. Edward? Okay. So if no question, can you all write the okay here? So we know that you still can catch up the component. Okay, very good. Thank you, Miss Wei, Miss Kai Xing, and also Miss Iki. So you three always very fast to answer me. Okay, so now already 3 p.m. But today we start slightly slower, so I will extend a bit. Okay, so before that, okay, let's do a very fast answering on this kind of the structure question in SPM. So in SPM, this kind of question maybe will have around one. This one I think is around 2 marks. And another 2 marks here. So for this kind of very short question, you can see this one is not the full question, but from this question ABC, there are 7 marks here. But for this 7 mark, it's very easy to get. Why? In SPM, compared to UEC or even the IGCSE, actually the way to answer, you just need to put the theory into the question and you get the mark already. First question, what is the type of permeability? Okay, so just now we say that there is only one type of permeability can be used to describe the plasma membrane, right? Okay, so the answer will be, let me change the font color first. Okay, it will be selective permeable. Or you can write semi, but me have a dash here, permeable. Okay, And then secondly, they ask, glucose is observed to not able to enter the plasma membrane directly. So they need two possible reasons. Okay, so what reason? Okay, glucose. Just now we check our table. Okay, so glucose is what kind of substance? Glucose is large, is water soluble, or you say lipid insoluble. Okay, so this will be the answer. Okay, so this table can bring you to the direction you want. Okay, so glucose is, because glucose is large molecule. Okay, glucose is also lipid insoluble. Okay, straightforward, 2 marks you get already. Okay, next one. This one is a level 2 question. In SPM, in future, when you all attend the first class of the revision camp, I will explain. In SPM, there are 3 levels of question, and what kind of question can be come out in SPM based on the mood of question. Okay, this one is under level 2. Okay, they say ADP and molecule Y were found to be present after the carrier molecule carry out process X. Okay, so from this diagram, we can see that actually this one is from high concentration to low. Here also high to low. For here, it seems like if the ATP is applied here, the direction will be like this. Let me change the black color. Okay, it will be like this. Okay, so if the direction is from low to high, oh, so we know that actually this kind of question is very easy. I know lah, it's an active transport question already. Okay, so then they're asking the question, what is molecule Y and process X? 2 marks. Okay, process X, 3 marks for you. Active transport. Okay, easy. How about molecule Y? So for molecule Y, it can be, we know that you can see ATP become ADP plus something. Okay, so this one is the knowledge that we need to learn from other chapter. But since you know that SPM never come out the question stand alone, normally they will stand like the UEC from FUMU or Chinese high school. The question mostly will be the combined chapter question. Okay, so we need to understand from other chapter, ATP actually means that the full name is the adenosine triphosphate. Okay, ADP is what? ADP is adenosine diphosphate. Okay, so we can see the answer here very easy now. Di and tri. Tri means 3. Di means 2. Okay, so 1 phosphate is gone. Okay, so mostly the molecule one will be the phosphate molecule. Okay, hey, 2 marks is here. Okay, and then last one. List 2 characteristics of process X that can be observed from diagram 1. Okay, so, oh, this question seems like complicated a bit. Okay, so for SPM, when they say the question request you must be observed from the diagram. So although we know that for active transport, we have so many characteristics, right? But the thing you can only choose is only the one that can see from the diagram. So for this 5 point we see here, okay, can we know the name of molecule here? No, right? Don't know. Okay, so you cannot write about the type of substance involved. Okay, can we write about the movement of the substance? Yes, we can write because we observe that it's from the low region to the high region. That could be the first point. Can we write about the trend of concentration gradient? Yes, you can write because actually we can see this one is against the concentration gradient. Can we write about the energy? Yes, we can see the ATP here. But sometimes in the exam, they will purposely hide the ATP. They will only show you the direction and also the number of molecule. Okay, if they are not ATP, if they say based on the diagram, okay, so don't write about ATP because you never know that the teacher is either try to cheat you or not. Okay, so for this one, we have three choices for this time. So we can say the process X, the movement of process X is from low con to high con. Okay, but in exam, please write in full sentence. Today I write short form for you all to understand faster. Okay, secondly, the movement is also against the concentration. Process X is against the concentration gradient. Okay, and last point, the process X require ATP. Very easy. You have three choices to write in answer, but you only need 2 marks here. Okay, so if you can understand either 2 of them, you can get the marks fully in this question already. Okay, so yeah, everyone, any question from this question? Oh, it's very round cold. Any question from this question? So if everyone here is okay, can you type a okay here? Okay, Miss Wei En is so very fast. Okay, so send to Miss Iki and Kai Ching. Thank you very much. Okay, so next one, our last part of the day. Okay, so for essay question, maybe you all will experience the answer in the actual revision camp. But since you all joined the group, right? So if you all finish the question later, you all can send the answer to me. I will mark for you for sure, for free. Don't worry. Okay, so last part of the day, we talk about the isotonic, hypotonic, and also the hypertonic. Okay, so for this diagram, it actually is almost stack everything already. But what I want to emphasize is you need to know the concentration of solute and also the concentration of water. Okay, so this brings a new concept to us today. Okay, so for this kind of the substance, we know that we have a new term called as concentration of solute. And the formula is what? Because we know that in chemistry, we learn solute plus solvent equal to solution. So normally all the thing in our reality is solution. Okay. Concentration of solute means it's a solute potential. Okay. Concentration is of solute in solution. If the concentration of solvent in solution. So in most cases, if they say that mixed with water, so it means it's the water potential. Okay, because here is water. So it will be the water potential. Okay, so I put a star theory here. As long as you remember this, you can solve the question already. Superstar theory. Okay. Solute potential and liquid potential will be having the opposite trend against each other. It means that what? When the concentration of solute potential is high, okay, water potential will be low. Same apply to when the water potential is high, solute potential will be low. Okay, so they're never able to have both very high concentration, because you can imagine if I use the illustration, I put a cup of water here. Okay, so if you have a lot of solute, okay, solute here. So if you have a lot of solute, so do you have space to accommodate water? So if high solute, so if I draw another color with water, so means low water potential. Okay, same apply to another one. If we have less solute, okay, so we can have a lot of water because in the same volume, okay, so the water is very so high water potential. Okay, so based on this, okay, so you all just need to remember, so when the solute move from where to where, so the water will also follow to move where to where. Okay, for example, like for normal condition, for isotonic condition, so it means that actually the concentration of solute and water, everything are in balance. Okay, so you're referring to solute potential equal to water potential. Okay, so here will be the same. For example, like here and here. So here is the water potential is same. Okay, for solute potential, it will be also same. Okay, but if for hypotonic condition, how about the water potential? Hypo means actually the water is enter. So means there are a lot of water enter it. So means high water potential outside. Low water potential inside. Okay, so the water enter. Okay, but if you think about the solute, so when you do the question, you need to think about, so if the water potential outside is very high, means the solute potential is very low. Okay, so the solute inside is very high. So if there are higher solute potential in a component, you can think the water for sure will enter one. Okay, because water potential become very low now. Okay, same apply to hypertonic condition. So for hypertonic condition, the water will come out. Why? Because this time the water will be like this. So you then higher water potential outside. To lower water potential. Same apply to the solute. So inside is having lower solute potential. Outside is higher water solute potential. Okay, so this will cause the red blood cell to shrivel, become smaller, or we call them as crenation. For the one that bursts, we say the lines, or we say you can write burst. It called as hemolysis. Okay, but for the plant cell, the description will be totally different. Okay, so before we end the class today, okay, I talk again about it. So when the plant having not enough water, or we say just isotonic, not the hypotonic condition, so the plant will having a flaccid cell. What is the meaning of flaccid? Flaccid means soft. Okay, due to not enough water. Okay, but if you water your plant in your house every day, so actually it form a hypertonic solution around the plant cell. Okay, it become turgid, so it turn very hard due to high water concentration inside the cell. Okay, and for the last one, oh, this one says so severe. We say it's a plasmolysis. It means that all the water is lost. Okay, here is the empty space. Okay, so this one means the water is lost surrounding. But if you ask me, so teacher, if the cell become plasmolized already, can the cell be regained to flaccid or turgid after I water the plant? Yes, this is a very common question to be asked in SPM also. So they say, okay, so after certain day, okay, the cell become the person water the plant. Okay, so you can say that actually there can be turgid back, and this is a process of deplasmolysis. Okay, deplasmolysis means that the cell regain already. Okay, recover. But for sure, before that, you must say the cell plasmolyze first. If not, there are no deplasmolysis. You just need to state that the cell become turgid. Okay, so that's why most of the students that I teach before, they say, so teacher, can I just write turgid without deplasmolysis? Yes, you can. But if the exam, the question is in the essay, if you write the deplasmolysis, maybe you can get 1 extra mark. Okay, so it depends on whether you want to get the extra mark or not. Okay, so yeah, so I think that's all about our class today. And since you know this one is a trial class, is a 1 hour version, right? So actually for every live session in future, so it will be about 1.5 to 2 hours, depends on whether you all having a lot of questions or not. If there are less questions, maybe we can finish the class around 1.5 for the live session. But if you all cannot attend the class during the date that I state in the schedule, you all can watch the video and ask us the question in the private group, no matter you want to ask in Facebook, Discord, or even in the Google Classroom. We are ready for you all. Okay. So any